Okay, now let's look at nonlinear regression or fitting a nonlinear equation through the data. So if you have a relationship like this, then you can fit a straight line. That's not a problem. But if you have a relationship like this, if you fit a straight line, okay, that's not as good as a situation where you are able to fit a line like this. If you're able to fit a line like this, that will do the prediction much better than if you do a straight line. Okay. So here is an example that we're going to use to illustrate this. So we have a study of the impact of weight on miles per gallon. So we'll do a linear regression and then we will do a nonlinear regression for this. Let's head over to Excel. Okay, so here is MPG and that's weight. So let's first define the variables. Okay, Y is MPG. We are trying to predict miles per gallon, and X is weight, right? So let's plot this. So Y is on, if X is the first column, then we can highlight both columns at the same time. But since Y is the first column, let's plot that. Okay. Now we don't have X in it yet, so select data, edit, and insert the weight. Weight as X. All right, so now we have okay, so miles per gallon. Okay, so like that, right? So if we try to fit a straight line, then it would be, okay, I can do an intercept of Y first, comma X. All right, and then slope Y first, and then X. So that will be our equation. Okay. So our estimate will be, so we can do an R squared Y and X. Okay. And we get 74%. So that's our linear equation. Okay. Suppose we want to do a quadratic equation. Okay, like this. So let's define the variables. Okay, so Y is MPG still. So we have X of 1 is weight. So Y is still MPG. So X of 1 is weight. X of 2 is weight squared. Right? So what we need to do is we have X of 1, which is weight. We need to set up another column for weight squared. Okay, so superscript, right? So take weight and square that. All right. So now we are ready to run the regression. All right. Okay, MPG is Y, and then weight and weight squared. All right, labels, and we'll use that cell as the output cell, and we have the results. Okay, so we are interested in this part. So the equation for us now is Y hat equal to that plus this times weight plus this time weight squared. So here is our equation. So r squared is that. So r squared has improved quite significantly. And you can see that in the scatter plot. You can see the scatter plot is kind of a non-linearity. We can even plot a trend line. Okay. So you have to go to more options and select polynomial of second degree. So that's the square, and when we do that, you see that this line fits much better than a straight line. Okay, now how would you use this estimated line for prediction? So the question, so what is the estimated miles per gallon of a vehicle weighing 3,500 pounds? So weight is in 1,000 pounds. So 3,500 pounds, the x sub 1 value will be 3.5. Don't plug in 3,500. That would give you wrong answer. And then x sub 2 is the square of that. Then y hat is, it's that 79.8 minus 30.2 times 3.5 and 3.4 times 12.5. So which is intercept plus b sub 1 times x sub 1 plus b sub 2 times x sub 2, which is weight squared. So that will give you the estimated miles per gallon. Now you have to be careful with setting up regression, nonlinear regression in this fashion, because remember we talked about multi-collinearity. Here x sub 1, what do you think is the correlation between x sub 1 and x sub 2 going to be? Okay, 99%, because weight squared, so it's weight squared is weight squared. So these two are very highly correlated. So you have to be careful not to overdo this nonlinear regression, fitting of nonlinear regression.